Hello, this is Mrs. Merrill. Today we're going to be talking about Learning Target Objective 2.1, which is to identify angles formed by parallel lines. To begin, we're going to look at 3 definitions that we're going to need in order to analyze some diagrams today. So the first term you see is parallel lines. Parallel lines are 2 lines that are coplanar and do not intersect. Now, coplanar, remember, means on the same plane. So if you think about 2 lines that do not intersect that are on the same plane, you could imagine train tracks. You know how the train tracks never intersect, they just keep going at the same distance apart. So that would be your image of parallel lines. Then we contrast that with skew lines. Well, skew lines are lines that do not intersect as well, but they are not in the same plane. And I'll show you an example of that in the diagram in just a minute. And then our third term today to look at is parallel planes. And parallel planes are 2 planes that do not intersect. Now, let's take a look at this diagram to help us with these new concepts. In the diagram, remember when we start out, we always analyze the diagram, we try to figure out what's going on in the diagram, and then we try to answer the questions. And today we have 4 questions that we want to answer about this diagram. So, I see a cube. I see 6 faces that make up that cube. The faces are squares. You know, I see, like, for example, the face ADHE. Well, you know, that's a square. And then I've got 6 squares that are put together to make that cube. I've noticed that also on the diagram, the dotted lines represent what I'm not seeing. Dotted lines usually represent something that is hidden from view. I remember that. I know that when I see those little arrow things, I remember that usually means it's a line. I see capital letters. And I remember that that means points. So basically what we've got here, now I'm looking at those dotted lines, and the dotted lines in this case are not meaning hidden from view. That's just what they're showing you as the boundary of that cube, meaning that it doesn't really stop there. And then I've got the points A, B, C, D, E, F, G, and H. And then I've got the 6 faces, which are squares. So that's pretty much what I can tell by the picture. Now let's try to answer the question. So letter A. I want to find a line that is parallel to the line AB and contains the point D. All right, so it's got to be parallel to AB. That means it's got to run like train tracks, but it has to contain the point D. So what do you think? Are you thinking the line DC? Me too. All right, letter B. Let's see if we can analyze the diagram to find a line that is perpendicular to the line AB and contains the point D. Now you'll remember from our previous lessons that perpendicular means the 2 lines meet to form a 90-degree angle, or a right angle, if you will. So look at the picture, look at AB, that's that top left, line AB. I want to find a line that would be perpendicular. That means it would meet it to form a 90. Perpendicular to AB that contains the point D. What are you thinking? Are you thinking the line DA? See, DA would be perpendicular, forms the 90 there at point A. And again, it contains the point D. All right, letter C. I want to find a line that would be skew to AB that also contains the point D. Now, remember what we said skew means. Skew is the idea that we have 2 lines that do not intersect, but they are not in the same plane. So take a look at, again, line AB and try to find a line that is skew to that contains the point D. Are you thinking DH? DH would be in a different plane than AB. DH is in that front plane, and AB is on that left side plane. They do not intersect. If you extend out line DH and you keep on extending out line AB, they're never going to intersect, but they are not parallel. They are in different planes, so therefore they are skew. And then letter D, name the plane or planes that contain the point D that appear to be parallel to the plane ABE. All right, so ABE is that leftmost plane. They've chosen to name the plane with 3 non-collinear points. I would have said 4. If I were naming it, I would have said plane ABFE. But remember, you can name a plane with any 3 points as long as they are not on the same line. So they've chosen to name it ABE. All right, so I need a plane, or planes, plural, that contain the point D that would be parallel to that plane. Well, what are you thinking? I'm thinking the plane DCGH. DCGH, that far right, the darkest of the blues. Those would be parallel planes. They would never intersect. And I think that's the only one. Do you see any others that would contain the point D that would be parallel? I don't believe so. So I think that's our only answer. All right, now I do have the answers for you on the next slide if you want to look at them, or you can go back and look at them later. All right, now we have 2 laws that we want to look at, and these laws are called postulate. A postulate in geometry simply means a law, but it's a law that we accept as true. In other words, it does not have to be proven. So here's our first postulate dealing with parallel, and that is the parallel postulate. The law says, if there is a line and a point not on the line, then there is exactly one line through the point which is parallel to the given line. So let's look at that. We have our line L, which is the blue one. And what this law is telling us is that there's only one line that we could draw parallel to L that would go through that point P. Do you agree? If I were to slant that line a little bit through P, in other words, maybe tilt it up a little bit, or maybe tilt it down a little bit, that line would not be parallel to L. So there is only one way, only one line that I can draw parallel to that line L that would go through that specific point P. All right, now we have what is called the perpendicular postulate. Remember what perpendicular means, that the lines would meet to form a 90-degree angle or a right angle. So here is the perpendicular postulate. If there is a line and a point not on the line, then there is exactly one line through the given point which is perpendicular to the given line. Now let's take a look at that. Again, we have line L in blue. And what this law is telling us is that there is only one way that I can draw a line that will form a 90-degree angle that goes through P to L. So you see in red, there's that one line. Notice the line in red goes through P, and when it hits line L, it forms a 90-degree or a right angle. So there's only one line that would go through P that will be perpendicular to L. All right, now we have 4 more definitions to end today's lesson, and these are definitions of angles that are in pairs. In other words, I'm going to have angle pairs here. I'm going to have 4 different names. I'm going to find corresponding angles. I'm going to find alternate exterior angles. I'm going to find alternate interior angles, and I'm going to find consecutive interior angles. Now, these are all angle pair names, which means you have to have 2 angles together in order to call them these angle pair names. So, for these angle pairs, let's take a look at the diagram that we'll be using to find these angles, and that is a diagram that contains a transversal. Now, a transversal is a line that will intersect at least 2 or more coplanar lines at different points. So in the picture, the sort of vertical looking line, that is your transversal. Notice it intersects 2 lines. Now, when you have this type of situation, we have a minimum of 8 angles formed. Notice my angles 1, 2, 3, 4, and then on the bottom intersection, angles 5, 6, 7, and 8. So in this, we're going to look now at the position of where the angle is along the transversal, And that is going to tell us what specific name we're going to call those angle pairs. So let's look at the red ones first. Angle 1 and 5. Notice by their position, they are both top left in their intersections. If you look at angle 1, 2, 3, and 4 as the top intersection, and then angle 5, 6, 7, and 8 as a bottom intersection, both angle 1 and 5 are in the top right. Sorry, I don't know my right from my left. Top left of their intersections. So 1 and 5 would be corresponding angles. Now look, let's go top right now. Look at 2 and 6. See how they're both in the top right of their intersection? They're corresponding. Look at 3 and 7. They're both bottom left. And then, so they're corresponding. And then if you look at 4 and 8, those are both in the bottom right of their intersections. So those are corresponding angles. So 1 and 5 are corresponding. 3 and 7 are corresponding. 2 and 6 are corresponding. And 4 and 8 would be corresponding. Now let's look at our second angle pair name, which is alternate exterior. All right, so the alternate exterior, alternate means opposite sides of the transversal. Exterior means angles on the outside of the diagram. In this picture, 1, 2, 7, and 8 would be exterior angles. So now give me the exterior angle pairs that are on opposite sides of the transversal. So you've got 1 and 8 and 2 and 7. 1 and 8 and 2 and 7. And then we have, let's take a look at the next angle pair names, which would be alternate interior angles. If you look at the interior, you've got 3, 4, 5, and 6. Those are interior. See how they're on the inside of the diagram. Alternate means on opposite sides of the transversal. So 3 and 6 would be an alternate interior angle pair, and 4 and 5. And then last here, we have consecutive interior. Consecutive means beside each other, and then interior on the inside. Remember, our interior angles are 3, 4, 5, and 6. So consecutive interior would be 3 and 5 and 4 and 6. Now, I've got something here I want us to try before we end today. So let's look and see if we can find the angle pair names for each of these. All right, so corresponding. Give me some corresponding angles. 1 and 5, 3 and 7, 2 and 6, and 4 and 8. They're in the same basic position. See, you have to kind of change your perspective here. See, you got it, it's kind of slanted there. So you got to change your perspective. All right, letter B, alternate exterior. Opposite side of the transversal on the outside. 1 and 8 and 2 and 7. All right, how about letter C, alternate interior. Opposite sides of the transversal on the inside. 4 and 5 and 3 and 6. And then the last, letter D, we have consecutive interior. Same side of the transversal on the inside. 3 and 5, 4 and 6. And here are your answers if you want to check those later. That's all that I have for today. Thank you very much for listening.